So we're kind of approaching 15 minutes. It's been about 11 or 12 minutes, so you should be kind of approaching the end of part C now. I see a couple of people are finished, so I'll give you one more minute and then we'll have a look at the answers. Right, let's have a look. So the first one is to solve this inequality. 2 minutes, don't think it'll take 2 minutes, so it's no, I made a little project for myself yesterday. You all have trouble booking on GNIB, don't you?
Yeah.
So I wrote a little program to keep checking when there's appointments free and to send me a text message when something becomes free to book. So that's why I'm checking my phone to see if it works. So that wasn't the text message. So if I get a text to say there's an appointment free, I'll let you know, because obviously I don't need to book an appointment. I just see if I can do this. Right, 5 less than or equal to, I think I'll take the 4 to the left and the 2x to the right. Like this. Yeah? So, does everybody get this? X bigger than a half? Yep. Yeah, you could have written it like this. X, sorry. You mean the x on the left, is it? Larger than a half is fine. Yeah. Minus a half? No, minus. No, I think something went wrong if you have a minus in your answer. Right, 2. Now, what's the answer for number 2 here? Are you, you're saying 4, but I think you mean another number. X, so what do I write as the answer? X is bigger than 2?
X is bigger than 2 and union with X.
Yeah. Yeah. The way I like to do it though is like this. It just makes it so much clearer. Because you have x plus 2, x minus 2 bigger than 0. So your two answers, it has to be, as you say, smaller than minus 2 and bigger than 2. The answer. Okay. B now. What have we got here? Yeah, although not for the first part actually. How do I do the first part here? It was find the remainder. Remainder theorem, yeah, very good. So it's going to be 2 cubed plus, plus 2 times 2 squared minus 2 minus 2. 8 plus 8 minus 4, 6 to 12, is it? You all got 12?
I use long division.
Say again?
Long division.
You can use long division. It's shorter, just, yeah. And number 2, they ask you to do a long division anyway.
Can I go back to the question page?
Yeah. You see? Good. X plus 2 divided into x cubed plus 2x squared minus x minus 2. Yeah? So that's x squared. That's x cubed plus 2x squared. That's nice. Double cancelling. Minus x minus 2 leaves you with minus 1 just. Factorise completely. Well, the factors here are plus 1 and minus 1. So The answer is x plus 1, x minus 1, and x plus 2. Strangely, they didn't ask me to graph. Part C. You want to solve, see, it's a very nice question actually, because everything is set up so nicely, because they already give you the y. I know, it's me. So, we'll sub in the y. X minus 4 squared minus 3x minus 2 times x minus 4. That should equal 9, yeah? So, x squared plus x squared minus 8x plus 16 minus 3x minus 2x plus 8 equals 9. So that's 2x squared minus 8 minus 11 minus 13. So 24 minus 9, isn't it? 15? No. Yeah? Yeah? So you get 3 over 2, and we don't forget the y or you'll lose marks. So 3 over 2 minus
2.5.
5 over 2 and 1. It's a very nice section B question, nothing too challenging for us to do. Let's see what we can do next. So we can't do number 2 yet because there's stuff in it. Can't quite do number 3. We could do part of number 2, but maybe I should find a different exam paper, it might be better. Let me open up a different exam paper. Let's see. Let's see what we got in section D here. Right. I'll give you a choice. So we can either do another algebra question, or a sequence and series question, or a exponential and log question. Yeah, don't listen to this guy.
Can we actually do the last question and the last recess that we did before we went on holiday?
You want to do that question?
That insane practical question.
Okay. Let's do that.
Problems on the exam.
Yeah, that is true. But that was a different exam.
Yeah.
You know, things change. You know, things move forward. Life goes on.
That one was confusing me.
Oh, it was wonderful, wasn't it?
Yeah.
It was wonderful. I loved it.
Like I felt like it was an arithmetic inside a geometry or something like that. I'm not sure.
So this is for people who wanted to try another Amjad. For people who wanted to try another mid-semester exam, there was a resit on Moodle. Let's have a look at it. Oh, sorry, do you have it? Yeah, you do. Yeah, some of the questions were fine. Like number 1 was perpendicular. Number 2 was complete the square. Number 3 was the first 4 terms. Number 4 was a linear inequality. Number 5 was surds.
They were all easy to learn.
So that's section A, and then this is my section B in the midterm reset. by trial and error, find a root between -3 and 3 for that one. I think that was okay. You have to keep guessing until you got a root.
I think it was 1 and 3.
Yeah, but why not use 3?
Because it's
Very good, very good.
I think
Divide the cubic. I think that's okay. Yep. I'm talking here. Divide the cubic. So that one was okay. What about this? By using the sketch of the cubic, find x and y such that x is greater than 0, y is less than 0. How do we do? Number 2 you definitely don't like.
yeah, it's B2.
Yeah, I think how about we do this one together? Yeah, so can we all see this off? Alright, let's zoom in a bit. Can we see okay?
Yep.
Just write the cubic down and then I'll copy it here. Okay, so I ask you to try to find roots that could be these numbers. So obviously 0 is not going to work, and well, we can keep trying, but I'm sure somebody has.
It's 1.
3 is not in this list.
Yeah.
Yeah. Is it 1? 1 looks good. So x equals 1, so x minus 1 is the, do I ask for the root or the factor? The root, so that's the answer there.
And then long division.
Yeah, part 2 now is I want a long division. Okay, so that's alright as well, isn't it? Hold on, write it down again. Right, so what's the first one here? 6x squared. 6x cubed minus 6x squared, right? 9x squared minus 90x. Next is 9x. 9x squared minus 9x. Minus 81x. Plus 81. Minus 81. Yeah? Yeah, fine. That's the answer for that. Again, no problems, right? Now, part 3. I want you to make a sketch. So it'll be quite useful to factorize this. So I think I can take 3 out. And this has factors? 2x, x, 9 and 3? Yeah. Like, yeah? So if you were to draw the cubic, there's a root at 3, there's a root at minus 9 over 2, and we have a root at 1 as well. So if I draw the cubic, where is x and y both positive? Well, x is only positive here, okay, and y is only positive here. No, sorry, I said where is x positive and y is negative. So y is negative here. Yeah, so the answer is find the set. So the answer is 1, 3. Yeah. Yeah? You didn't believe him when he said
No,
this?
he wrote 2, and I kept telling him it's not 2.
The number 2?
Yeah.
He's right, it's not 2. Yeah. Oh yeah. Hey, what's wrong? What's the question?
I don't remember, like we were talking about the exam.
The N one.
Yeah, it's another part, next part now, yeah. I can't hear her. Yes? Oh, sorry, here, is it? Yeah. You got it? Got this? Yeah. Right. Here's a fun one. Isn't it?
Yes.
Yes. Solve this.
It's almost the same.
Not that it's almost the same. It is.
It is the same.
M equals 6n squared plus 3n squared minus 90n plus 81. And m equals n minus 1. I want you to figure out m and n here. So it's a simultaneous problem. And the best method here is substitution. They're both equal to m, aren't they? So you can say n minus 1, oh sorry, that's just been a cube there, equals 6n cubed plus 3n squared minus 90n plus 81. Now what do I do next?
Equal to that one.
No.
Factorize.
Factorize, yeah.
And n is equal.
Because we have the factors from this cubic previously. What's it? N minus 1, 3, 2n minus 9, and then n. No, one of them has to be a plus.
Yeah, it's the 9.
It's the 9's a plus? Yeah. Or if you want to be a little bit more clear, let's just put the 3 in the front. Right. What's next now? No, actually. If you divide by n minus 1, you'll reduce the problem to a quadratic.
Yeah.
And you'll get two values for n. Will any of those values be integers?
No.
No. And I tell you in the question that m and n are integers.
Okay, fractions.
Yeah, which we don't want.
One of the values is multiplied.
In the quadratic?
Yeah, one of the values was 3.
3?
Yeah. I think.
Are you sure? I'm sure. Anyway, you're actually finished at this step. You can actually figure out the answer at this step. Can anyone see what the answer is?
N is equal to 3, right?
No. No. This equation has an obvious to me perhaps, obvious solution. Can anyone see its obvious solution? Anyone see obvious solution here?
M is equal to 1.
Why?
That would be the only value that has to be zero.
Yeah, but why? It is n equal to 1. Because if n is equal to 1, what will this equal? 0. And what will this equal? 0. And if n is equal to 1, m will equal here 0. So, anyways, I didn't ask for the m, I just asked for the n. The n is 1. Now, n is not 3, because although 3 will make this side 0, it doesn't make this side 0.
Yeah.
And you can't divide by n minus 1. Why can't you divide by n minus 1? Question or? Oh yeah. Why can't you divide by n minus 1? That's some people suggested. Yeah. Yeah, you can't divide by 0. Yeah. If n minus 1 is 0. And it actually is 0 here, so you can't divide. Alright. I thought you got it when you suggested factorizing, but
But
nearly.
I messed up with that.
Yeah, nearly. Okay, that was a tricky one, and now on to the last one. Oh, look at it. Look at all these words. It's wonderful. I made it an Arabic question.
Yeah.
Oh, I thought you might find it. I thought you might find it more engaging if if I was being culturally,
Yeah, the only confusing thing is I don't know if it was 1.5 trillion barrels total or 1.5 trillion barrels every year. Like.
Well,
Yeah.
yeah, I thought, reserves would mean the total.
Okay.
Yeah. Let's have a look at this one now. This was, there's 1.5 trillion barrels of oil in the world. And 34 billion barrels of oil are used every year. Now, we have a problem with billion and trillion, so rather than using billion and trillion, what I'll do is I'll say billion is B, okay, and trillion is 1,000 billion. So, first things first, I'll just change 1.5 trillion. I'll just change 1.5 trillion into 1.5 times 1,000 billion. Yeah? B for billion. 1500 billion. Billion. Okay? So that's how much oil there's in the world. 1,500 billion barrels. And in year one, how much is used? I say 34 billion is used. In year two, how much is used? Well, it'll be more than 34 billion. How much more? I say in the question, 0.5% more. Of a percent.
Yeah, each time.
Yeah. Yeah, 0.5%.
And then you add it to the 34.
Yeah. So, how do I increase a number by 0.5%? What would I multiply it by? Now, I think carefully, what am I multiplying it by? If I wanted 0.5% bigger. 100.5? No, that would make it 100 times bigger. I want to make it 0.5% bigger. That would make it 150 times bigger. Yeah. Yeah. That would make it 5% bigger. Yeah. That makes it 0.5% bigger. Yes. If you put percent as being 1/100. Yeah, no, that's fine. Some students don't like doing that though. But you're right, it's the same. So 1.005 makes it 0.5% bigger. And then it's 0.5% bigger again. So it's GP, right? It's GP where this is the OR and this is the A. But when you add all this up for the n number of years, what should the total be? You know actually what the total should be.
1.5 trillion.
Yeah, 1.5 trillion. Because that's what the total consumption should be. So what you basically have is this. Yeah, sum n should equal 1,500 billion. So the GP sum is A 1 minus OR power n over 1 minus OR. That should equal 1,500. Okay, so let's just have a look here. So that is 1 minus 1.005 power n will equal 1,500 divided by 34 times minus 0.005. Okay, so that is 1.005 power n. Bring that to the right, bring that to the left. 1 plus 0.005 times 1,500 over 34. I won't use the calculator just yet because I want to be as exact as possible. Okay? So there's only one thing left for me to do is to figure out the n. And how can I get the n here? Yeah. The n will be log base what?
Base 1.0.
Yeah, very good. And then of 1 plus 0.005 times 1500 over 34. So let's see what the heck happens.
Minus 49.9.
I must have made a sign mistake then if we got a minus. No minus here, dude. 39.96.
40.
Yeah! I wonder if I actually said 40. I shouldn't really have said 40. I suppose, will I be a jerk? No. I'll be kind. It's really 39. It's really 39 because it can't quite make 40 years. But it's possible that you could have gotten 40 if you used decimals sooner than I did, because I waited until the last moment to calculate. So it's exactly this, but if you said 40, I guess that's okay. Yeah, I would be happy enough with 40. Yeah. So 40 years, roughly. Roughly. Yeah? Did anybody get that? I don't think so. No? Doesn't look too bad now, does it?
It's just the rate. That's the question.
The 0.5%? Oh, actually no, I was a jerk, sorry. I put the answer in as 39 on the Moodle quiz. Yeah.
39
Huh? 39 is what I went with, yeah. Because it, like you were saying, it doesn't quite make it to 40. It won't last 40 years. Yes, exactly. If you said it'll last 40 years, you'd be a dirty liar. Okay. That was a hard one, wasn't it?
Totally unrelated to the expression about the question.
What do you mean?
The word you use, the 0.5%, the reserve, it's not very precise to understand.
Yeah, unfortunately though, sometimes, in the maths exam, they use language that really makes you think. You have to think hard about what exactly they mean, unfortunately. Right, let's have a look.
If it was 1.5 trillion recurring, then it would be 2,000 something years. That's what I did.
Oh, it's 1.5 trillion appeared every year.
Yeah.
That would be wonderful.
Yeah.
That would be, but
how much time would it take for the rate of consumption to catch up to the rate of reserves?
oh, I see. Okay,
that's what
yeah.
I did.
And you got a number like
2,000 something years.
oh yeah, so there'll be no trouble for Saudi Arabia anytime soon then. It'll be good for another 2 millennia. This is good. Yes. And you felt that answer was right or wrong after you got it?
Wrong. I felt it was wrong.
Yes.
It was obviously wrong. But
Yeah.
Kind of
Yes, 2000 is a good amount of time, isn't it? Okay, so I think what we'll do, it's only a couple of minutes, so let's see. We did a sequence and series. Yeah, what I want you to do is, I want you to get started on a question I'm going to put up, and we'll have a look at the answer next week if you want. It's from last year's end of semester 1 exam. It's an exponential and log question in section B. So it's if you want to have a look here, it's this one here. Okay. Right. So this is a good one because it mixes a practical with some equations here. So since we just finished exponential and log, this will be a nice one for you to try. So can you give this one a go now? It should only take you 15 minutes. But you can finish it at home. Just get a start on it now.